Hello everyone, welcome to the next lecture. In today's lecture, we'll study about operators. Operators are the symbols that are used to perform specific operation on the operands. In Java, we have many types of operators. We have unary operators, arithmetic operators, relational operators, logical operators, bitwise operators, ternary and assignment operators. We will study each of them one by one. So let's first start with the unary operators. Unary means one. So unary operators are those operators which take only one operand. So we have 5 unary operators in Java. We have increment, decrement, minus, logical not and bitwise not operator. First let's see the increment operator. Increment operator is denoted by plus sign. It increases the value of the variable by 1. Arithmetic operator can be used in two different ways. It can be used in prefix or postfix notation. So prefix means I'll first write the operator plus and then I will write the name of variable. If I write it in postfix notation, it means first I will write the name of the variable and then I will use the plus sign. So both of them increases the value of the variable by 1. Now you can see in both of these notations we are using only one variable. Increment operator just takes one operand, that's why it is a unary operator. Let us take an example to understand its usage. Suppose I have a variable a whose value is 5. If I write a plus, so a value is increased by 1. A becomes 6. If I write plus a, here also a value increases by 1, so a becomes 7. Now both of these are used to just add 1 to the value. So what is the difference between prefix and postfix? The difference comes when we are performing more than one operation in a single line. Let's take an example. I have a variable a whose value is 7. I have two more variables b and c. Now I am assigning b a plus. In this line, two operations are being done. I am incrementing a's value and I am assigning the value to b. So now the order of these two operations depends upon the usage of the notation. Here I am using postfix notation. So if I want to break down this step, I can write it as b is equals to a and then a is equals to a plus 1. I am incrementing a afterwards because I am using the postfix notation. So b is equals to a is 7, b becomes 7 in this line. Now a is incremented, a becomes 8. If I had used this, so c is equals to plus a. What happens here is, here I am using prefix notation. So when I will break down this step, I'll first write a is equals to a plus 1 and then I will write c is equals to a. Now first the value of a is incremented, a is 8. So here a becomes 9. Now this value is assigned to c, c becomes 9 here. Let's take one more example. In this example a is again 7. Here I am printing, so I am using system dot out dot print a plus. Here also in this line you can see two operations are being done. A value is incremented and I am printing the value on screen. So if I want to break down this step, since I am using the postfix notation, the a value will be incremented afterwards. First we will print the value of a, print a, and then a value will be incremented. Afterwards we'll write a is equals to a plus 1. So first a value 7 will be printed on screen, then a is incremented, now a becomes 8. So if I had used system dot out dot print plus plus A. Here prefix notation is used. So if I want to break down this step, I will first have to increment A and then I can print its value. So if I break it down, I'll first write A is equals to A plus 1, and the second step will be to print value of A. So A is 8. If I increment A again, A will become 9. Now I am printing the value of A. The current value of A is 9. So 9 will be printed. The next unary operator is decrement operator. It is denoted by minus sign. It decreases the variable value by 1. It can also be used in two same ways, prefix and postfix. So if I write it in prefix way, I will write the operator first and then the name of the variable. And if I have to write it in postfix notation, I will first write the variable name and then minus. Let's take an example. I have a variable A whose value is, let's say, 10. If I write A minus, the value of A will decrease by 1. A becomes 9 here. Again, if I write minus A value will be further decremented. A becomes 8. Now let's take an example where we are performing sum and other operation along with the decrement operator. So the prefix and postfix notation make a difference. Let's say I have a variable A whose value is 5. I have two more variables B and C. B is assigned the value A minus. Here I am using postfix notation. So if I want to break down this step, the first step will be B is equals to A and the second step will be to decrement A. So second step will be A is equals to A minus 1. Now the current value of A is given to B, so B becomes 5 in this case. Now A is decremented, so A becomes 4. So if I had done C is equals to minus A, if I want to break down this step, prefix notation is used. So the first sub part will be A is equals to A minus 1 and the second step will be C is equals to A. So A is 4. Further, if I decrement A, it will become 3 and C will be equal to 3 in this case. Let's take one more example. In this example, we have A is equals to 5. So let's say we are printing system dot out dot print A minus. So this is the postfix notation. So if I break down this step, I can write it as print value of A, and in second step I will write A is equals to A minus 1. So the current value of A, that is 5, it will be printed and A will become 4. Now if I write system dot out dot print minus A, so this is prefix notation. So first I will have to decrement value of A and then I can do the other operation. So if I break it down, the first step will be A is equals to A minus 1 and the second step will be to print value of A. So A is 4. If I again decrement it, it will become 3. Now I will print 3 on the screen. The next unary operator is minus operator. It is a single minus sign. It is used as minus and then variable name, right? It is used to denote the negative value. So if I write int A is equals to 3 and int B is equals to minus A. So I am writing only one variable with minus. So minus is a unary operator. So here B value will be minus 3. So it denotes the negative value. I can also directly assign the negative value as int C is equals to minus 5. So here 5 is the operand and minus 5. So only one operand is used with minus sign. So minus is a unary operator. So we do not use plus sign because if I initialize something like this, int A is equals to plus 7, it is equivalent to saying int a is equals to 7. So both of them are same, so we do not need to write the plus sign. The next two unary operators are logical NOT and bitwise NOT. We will see them in logical and bitwise operators. Next we will see arithmetic operators. We have 5 arithmetic operators in Java. We have plus, minus, multiply, divide and modulo. Plus is used to add two numbers, minus is used to perform the subtraction, multiply gives the product of two numbers. This gives us the quotient when two numbers are divided, and modulo gives us the remainder when we divide two numbers. So they are used as this. So we use two operands with one sign. So all of these are binary operators because we are using two operands. If I want to use the minus sign, we write it as a minus b. For multiply, we also use two operators. Similarly, we use two operators for divide and modulo sign. So all of these are binary operators. So if I have two numbers, let's say a is equals to 13 and b is equals to 3. If I divide a by b, 13 becomes the dividend, 3 becomes the divisor. When I divide them, this 4 is the quotient and this 1 is the remainder. So a by b gives us the quotient 4, a mod b gives us the remainder 1. Whenever we perform any arithmetic operation on two variables which have the same data type, we get the result in that data type only. Whenever we perform any arithmetic operation on two operands of same data type, we get the result in that same data type only. But when the data types of these operands are different, we get the result in the wider data type. Let's say for example I add 5 and 2. Both of them are integers, so the answer will be an integer 7. But if I add 5.0 with 2, now this is double, this is an integer, double is wider data type than integer, so the result will be double only. Similarly, if I divide 9 by 2, 9 is an integer, 2 is an integer, so I do not get the result as 4.5. I get the result only in integer format. So the result here will be 4. If I divide 9.0 by 2 or 9 divided by 2.0, in that case I can get the result as 4.5. Let's see one more example. If I have two variables, a whose value is 9 and b whose value is 2, if I divide a and b and I store it in a float variable, so float c is equals to a divided by b. What will be the answer now? In this case, I am dividing integer by integer. So the result should be an integer only. So 9 divided by 2 will give 4. But I am storing that in a float variable. Now this 4 will be typecasted to float data type. So c becomes 4.0. Next we have relational operators. Relational operators are used for comparison. They compare two different operands and give us a Boolean value as output. So the first relational operator we have is equal to. It is denoted by double equal to sign. It checks if the two operands given are equal or not. So if I write a equal to b, if the value of variable a and value of variable b are same, then this expression returns true, otherwise it returns false. The next relational operator is not equal to. This is exactly opposite to the equal to operator. It is represented as an exclamation sign and then an equal to sign. It compares if both the operators are not equal. So if I write a not equal to b, if the values of these two operands are different, then it returns true, otherwise it returns false. The next relational operator is greater than. It is represented by greater than sign. It returns true if the first variable is greater than the second. So if the value of a is more than the value of B, this expression returns true, otherwise it returns false. Next we have less than. It is represented by less than sign. If I write A less than B, if value of variable A is lesser than value of variable B, then this expression is true, otherwise it returns false. The next operator we have is greater than equal to. It is denoted by a greater than sign and then an equal to sign. In this operator, if I write A greater than equal to B, if the value of variable A is greater than or equal to B, it returns true. If value of A is smaller than value of B, then it returns false. The last relational operator we have is less than equal to. It is denoted by a less than sign and then equal to. So if I write A less than equal to B, this expression is true if value of A is less than B or value of A is equal to B. In case the value of A is greater, then this expression returns false. Next we have logical operators. These operators take Boolean value as input and returns Boolean value as output. So the first logical operator we have is AND operator. It is denoted by double ampersand symbol. How does this work? Let us say we have two expressions E1 and E2. Both of them are Boolean, so the outputs could be false, false, first expression false, second true, first expression true and second false, or both expressions true. So if I apply AND on these two expressions, expression 1 and expression 2, AND is true only when both the expressions involved are true, otherwise it gives false. Here both the expressions are false, so AND returns false. Here one of the expression is false, so AND returns false. Here also one of the expression is false, so AND will return false. Here both the expressions are true, so AND will give true in this case. So this AND operator is taking two expressions as input. So this logical AND is a binary operator. Next logical operator we have is OR operator. The symbol for OR is double pipe sign. So we have two expressions E1 and E2. If the values are both the expressions false, first false, second true, first true, second false, and both true. Now if I apply OR operator to these expressions, so E1 or E2, the output will be true if at least one of the expression is true. Here both of the expressions are false, so the output is false. Here E2 is true, so the output will be true. Here E1 is true, so the output is again true. Here both are true, so the output is again true. Next type of logical operator we have is NOT. The symbol for NOT is an exclamation sign. It takes only one expression as input, so this logical NOT is a unary operator. So let us say we have an expression E whose values are false and true. If I apply NOT to this expression, it complements the value. So if I have false, the output will be true. If I have true as input, the output will be false. Sometimes a logical expression is not evaluated completely. The evaluation stops in between because we know the result of the expression before the complete execution of the expression. This process is known as short circuiting. Short circuiting may happen with logical AND as well as logical OR operator. Let's see an example with logical AND operator. Suppose I have a condition 1 and condition 2 and condition 3 and so on. So in this case, whenever I see any condition whose output is false, if I have condition 2 as false, even if all these conditions are true, the output cannot be true. So whenever I find any condition whose output is false, I need not evaluate the further expression because I know the output will be false. So this part of the expression won't be evaluated. Whenever I find any condition which is false and will stop its execution because the result is already false. Similarly, I have an expression involving logical OR operators. So if I have condition 1 or condition 2 or condition 3 or and so on. In this case, whenever any condition becomes true, I need not evaluate the further conditions. So let's say the condition 1 here is true. So all these conditions don't matter because the answer will be true. So all the further conditions won't get evaluated. This is known as short circuiting. When we stop the execution of an expression because we know the output before the complete execution of that expression. Next we will see bitwise operators. Bitwise operators work on individual bits of a number. So first we have to convert a number to its binary equivalent to get the bits, and then we perform the bitwise operation. So first bitwise operator we have is bitwise AND. It is denoted by a single ampersand symbol. If we have two bits, bit 1, bit 2, the values are both bits 0, first bit 0, second 1, first 1, second 0, and both bits 1. Now if I apply AND to these bits, AND will work similar to logical AND. So if any one of the bit is 0, AND will return 0. So here both bits are 0, so AND will be 0. Here one of them is 0, so AND will be 0. Here both the bits are 1, so AND will return 1 in this case. The next bitwise operator we have is OR operator. It is denoted by a single pipe symbol. So if I have two bits, bit 1 and bit 2, the values are both bits 0, first bit 0, second 1, first 1, second 0, and both 1. If I apply OR operation on both the bits, OR will return 1 if any one of them is 1. Here both the bits are 0, so OR will be 0. Here one of them is 1, so OR will be 1. Here also one of them is 1, so OR will be 1. Here both the bits are 1, so OR will return 1. The next bitwise operator we have is XOR operator. It is denoted by caret sign. So if I have two bits, V1 and V2, so the values are both bits 0, first bit 0, second 1, first 1, second 0, and both 1. So if I apply XOR sign on both the bits, so XOR returns 0 if both the bits are same. Here both the bits are same, so XOR will return 0. Here bits are different, XOR will be 1. Here also bits are different, so XOR value will be 1. Here the bits are same, so XOR value will be 0. Next bitwise operator we have is NOT operator. It is denoted by tilde sign. It takes only one bit as input. So if I have a bit B1 and if I apply NOT on it, it will just complement the input. So if the bit is 0, the output will be 1. If the input bit is 1, the output will be 0. Let's take an example. So I have int A 3 and B is equals to 6. Now if I had to do A and B, so this is single ampersand, so this means I have to do bitwise AND on A and B. So if I write 3 in binary, I can write it as 1 1. If I want to write 6 in binary, I can write it as 1 0 0. In Java, an integer takes 4 bytes. That means it is stored as 32 bits. For the sake of example, we'll just take 4 bits. So now if I had to do AND, 1 and 0, so one of the bit is 0, so AND will return 0. 1 and 0, again one of the bit is 0, so AND will return 0. Here also one of the bit is 0, so AND will return 0. Here both the bits are 0, so AND will return 0. So A and B will be 0. So if I had to do A or B, so if I represent A in binary, I'll write it as 1 1. B in binary is represented as 1 1 0 using 4 bits. So 1 and 0, one of the bit is 1, so OR will be 1. 1 and 1, both the bits are 1, again OR will be 1. Here also one of the bit is 1, so OR will be 1. Both the bits are 0, so OR will be 0. So this is equivalent to 7. So A or B is equal to 7. So if we do XOR operation on A and B, A XOR B, A is written as 1 1, B is written as 1 1 0, representing is using 4 bits. Now both the bits are different, so XOR will return 1. Bits are same, XOR will return 0. Bits are different, XOR will return 1. Bits are same, so XOR will return 0. So this is equivalent to 5. So A XOR B is 5. So here you can see AND, OR and XOR are taking 2 inputs. So they are binary operators. So if I want to use NOT operator, it is a unary operator. It will only take 1 input. So I'll say NOT of A. So A will be represented as 1 1 and all the other bits will be 0. So here 30 bits will be 0 because it is represented using 32 bits. So if I negate this, this will become 0, this will become 0 and all the 30 bits will become 1. Next bitwise operator is left shift operator. It is represented by double less than sign. What does it do? It shifts all the bits to the left and inserts a 0 at the right end. Let's take an example to understand. Suppose I have an integer variable A equal to 5. So it can be represented in binary as 1 0 1. Now this is an integer, so it is represented using 32 bits. So all the 29 bits here will be 0. So if I want to shift A left by 1, so the last bit, that is 0, it is removed and we add 1 0 to the right. So it becomes 1 0 1. All the bits come one position left and here a new 0 is inserted. So this becomes the new number. So this is equivalent to 10. Now if I shift A left by 2, here 2 zeros will be taken from the left and all the bits will be shifted 2 positions to the left. So 1 0 1 will be shifted 2 positions to the left, 1 0 1, and 2 zeros will be added from the right end, 0 0, and the 2 leftmost zeros will be removed. So this is equivalent to 20. So if I left shift 5 by 1, 1 0 is added, it becomes 10. If I left shift 5 by 2, the leftmost 2 zeros are removed and 2 zeros are added to the right, it becomes 20. Similarly, if I left shift 5 by 3, the leftmost 3 zeros will be removed and one more 0 will be inserted at the right end. So this will become 40. So you can see a pattern here. If I have n and I left shift it by k bits, it is equivalent to n multiplied by 2 raised to power k. Every time I left shift a number, it is multiplied by 2. But this formula holds only in case the removed bits are 0. If the removed bits are 1, this formula no longer holds. The last bitwise operator is right shift operator. It is represented by double greater than sign. It shifts all the bits to the right and adds zeros from the left end. So if I have A is equals to 6. It is represented as 1, 1, 0, and all the remaining bits are 0. So now if I write shift A by 1, the rightmost bit gets removed. So this 0 is removed. All the bits are shifted one position right, and a new 0 is added at the left end. So now this number becomes equal to 3. If I write shift A by 2, now what happens is the rightmost 2 bits are removed. So this 1, 0 are removed, and 2 more zeros are added to the left end. So this becomes 1, 0, 0. So this is equivalent to 1. If we have 6 and we write shift it by 1, it becomes 3. If I write shift 6 by 2, it becomes 1. Similarly, if I write shift 6 by 3, you can see this 1 will also be removed and a new 0 will be added from the left. So this will become 0. So you can again see a pattern in right shift. So if there is a number n and I right shift it by k bits, this is equivalent to n divided by 2 raised to power k floor. So every time I right shift the number by 1, it divides the number by 2. So if I right shift it by k bits, it will be divided by 2 raised to power k and the floor of the number will be taken. This formula holds irrespective of the value of the lost bits. Even if the lost bit is 0 or 1, this formula holds true. Next we have ternary operator. Ternary means 3. So ternary operator takes 3 operands. It is used as, first we write a condition, then we give question mark, we write 2 expressions. So expression 1 colon expression 2. So these are the 3 operands used: condition, expression 1 and expression 2. How does this evaluate? First we check this condition. If this condition is true, we execute expression 1. If this condition is false, we move on to expression 2 and execute it. So this operator is a one-line replacement of if-else statement. Let's take an example to see how this works. Suppose I have a variable int x is equals to 2. I have another variable y x greater than 5. This is a condition. Then I have a question mark 4 colon 3 semicolon. So this part is ternary operator. This is the condition. Then we have question mark. This is expression 1. This is expression 2. Now first we check the condition. X value is 2. X greater than 5 becomes false. So whenever the condition is false, we move to expression 2. So in expression 2 we find the value 3. So to left hand side y, the value 3 is assigned. Let's take one more example. So we have a variable which is an integer variable named marks. Marks are equal to 70. So now we have a string variable with the name result. Here first we will check the marks. Marks greater than 50 question mark pass, it's a string fail. Now this part is the condition. Then we have question mark. This is expression 1 colon expression 2. First we check the condition. Now marks are 70, so 70 greater than 50, it is true. Whenever the condition is true, we evaluate expression 1. In expression 1, we get the string pass. So this is stored in the string variable result. So the value of result is pass. So this is a replacement of if-else statement. We can also write the same code in if-else. With if marks greater than 50, then we assign string result as pass, else we assign string result as fail. Next operator is assignment operator. This operator is used to assign values to the variables. These operators are used in two ways: simple assignment operator and compound assignment operator. In simple assignment operator, we just have an equal to sign. The value on the right hand side gets assigned to the variable at the left hand side. So if I write int a is equals to 7, so this value 7 gets stored in an integer variable a. So if I write double b is equals to 2.5, this value gets stored in a double variable named b. I can also have a string variable. And on the right hand side, I will give a string value. So for giving string value, we use double quotes. And if we want to store a character variable, character ch, for storing a character, we give single quotes. Say character v. So in variable ch, which is of character data type, we have stored a single character v. Next we have compound assignment operator. In compound assignment operator, we use another operator along with the equal to sign. In Java, we have plus equal to, minus equal to, multiply equal to, divide equal to, modulo equal to, left shift equal to, right shift equal to, bitwise and equal to, bitwise or equal to, and bitwise XOR equal to. Now what do these operators mean? Let's see that with the help of an example. So if I have num plus is equals to 5. What does this mean? This means I will add 5 to the variable num and I will store that back in num. So this is equivalent to saying num is equals to num plus 5. So all these operators mean the same thing. First we will subtract and then store it back in the same variable. Let's take an example to understand this. So if I have a variable a whose value is, let's suppose 5, and I write a multiply equal to 2. So this means I will multiply the value of a by 2 and then I will store the result back in a. So this is just a shorthand notation of writing the same thing in this. I can also write it like this. This is just a shorthand notation of the same thing. With this line, a's value become 10. Next, if I write a modulo equal to 3. What does this mean? I will do a mod 3 and then I will store the result back in a. So 10 mod 3 will give 1. So a becomes 1 now. We can use all these operators with the equal to sign in a similar fashion. So whenever there is more than one operator in an expression, how do we decide which operator to evaluate first? For that we have precedence of operators. So precedence decides which operator should be given priority. So whichever operator has higher precedence, it will be evaluated first. Then operator with the lower precedence will be evaluated. But what if the precedence of the operators is same? Then we go on to associativity. So if precedence of the operators is same, then associativity decides which operator is to be evaluated first. It gives us the order in which we need to evaluate the operators with the same precedence, either left to right or right to left. So here there is a table which shows the precedence of the various operators used in Java as well as their associativity, which tells us the order in which operators with the same precedence are evaluated. You need not memorize the whole table, you will only need a few of them. So as and when you will code and solve the questions, you will understand which of them are important and you can learn only those. If I want to evaluate an expression irrespective of its precedence, we can use the parenthesis. So the expression inside the parenthesis will be evaluated first, even though its precedence is lower. Let us take an example. Suppose I have 5 multiplied by 1 divided by 2. Here I have two operators, multiply and divide. Their precedence is same, so we will go with associativity. So multiplicative operators have left to right associativity. So it will be evaluated from the left. So left operator is multiply. We'll do 5 multiplied by 1, it will be 5. 5 divided by 2, both are integers, so we will get the integer output. So the output here will be 2. If I have 5.0 multiplied by 1 divided by 2. Now, just as the last case, first we will evaluate the multiplication. 5.0 into 1 will give me 5.0. If I divide 5.0 with 2, 5.0 is double, 2 is integer, so the answer will be in double data type. The answer will be 2.5. Let us suppose I have 5 multiplied by bracket 1 divided by 2. In this example, even though the associativity is left to right, but we have used a parenthesis here. So this expression will be evaluated first. So first we will do 1 divided by 2. 1 is an integer, 2 is an integer, so this division will give an integer. This will give us 0 instead of 0.5. So 5 multiplied by 0, the output will be 0 in this case. So if I have 5 multiplied by bracket 1.0 divided by 2. So first we will evaluate this. This will give me a double value now. This will give me 0.5. 5 multiplied by 0.5. So in this case I will get 2.5 as answer. Suppose I have 5.0 multiplied by 1 divided by 2. Here first this division will take place. So this will give me 0. 5.0 into 0 will give me 0.0. Because 5.0 is double, this is integer, so double multiplied by integer is double value. If I have 1 by 2 multiplied by 5. So now the precedence of divide and multiply is same. So we'll go with associativity. Associativity is from left to right. We'll first evaluate the divide symbol. So 1 divided by 2 will give me 0. 0 into 5, this will also be 0. So you can see, changing the ordering of the expressions or the data types of the variables used, we can get different output. Now we will see some MCQs based on these concepts.
Let's move on to the MCQs. So the first question is, predict the output of the following Java code. So in the first line we have a byte variable a and we have assigned it the value 126. In the next line we have a plus plus. So adding 1 to 126 we get 127. Further we have another a plus plus. So 127 should logically go on to become 128. Now, can a byte variable store the value 128? Let's see. The range of a byte variable is minus 128 to 127. So a byte variable cannot hold the range 128. So these variables act in a circular manner. After 127, they go to the value minus 128. So instead of 128, we will get minus 128. Then we are printing the value of a. What is printed as output? It's minus 128. After this we have another line a plus plus. So adding 1 to minus 128 we get minus 127. Now we are again printing a. So we get the output as minus 127. So the next question is, predict the output of the following Java code snippet. So here in the first line we have a variable x and it is assigned the value of 20. Then we have the string answer and it is assigned a value based on the result of a ternary operator. So the first condition that we have to check is x less than 15. So the value of x is 20. So x less than 15 is false. So we will go to the second condition. In the second condition, we can see that there is another ternary operator. So this is an example of nested ternary operators. So the next condition is x less than 22. This is true. So we will go to the first condition. So in the string answer, medium is stored. And in the next line we are printing the answer, so medium will be printed on screen. So in this question we have to predict the output of the following Java code snippet. So initially we have a variable x and it is assigned the value 11 and 9. So let's see what's the value of 11 and 9. So 11 is written as 1, 0, 1, 1, while 9 is written as 1, 0, 0, 1. So what does AND operator do? If both the bits are 1, we get a 1. If either one of the bit is 0, we get a 0. So let's see what's the output of this. So 1 and 1, we get a 1. 1 and 0, it's a 0. 0, 0 is 0. And 1, 1 is again 1. So the answer is 9. So 11 and 9 is equal to 9. Further, we have a variable y. Its value is x XOR 3. So now y is equal to x XOR 3. So x is equal to 9. So we write it as 1001. 3 is equal to 0011. In XOR, if both the bits are same, we get a 0. If the bits are different, we get a 1. So 1 and 1, same bits, 0. 0, 1, different bits, 1. 0, 0, same bits, and 1, 0, different bits. So the answer is 1010, and this is equal to 10 in decimal form. In the next line, we are printing y or 12. So y is 10, so we write it as 1010. 12 is written as 1100. In OR, if either of the bits is 1 or both the bits are 1, we get a 1, otherwise it's a 0. So 00 is 0, 10 is 1, 01 again 1, 11 again 1. This is equivalent to 14 in decimal. So 14 is printed as the output. The next question is, which of the following is not a logical operator? So in option A, we have two ampersand signs which are logical AND. In option B, we have an exclamation mark which is logical NOT. In option C, we have a double pipe which is logical OR. In option D, we have a single pipe. This is bitwise OR. Thus the correct answer is D. Moving on, predict the output of the following Java code snippet. So we have a code snippet with us. In this we have declared a variable A, initialized variable B with value 20. So here B is equal to 20. Now we are calculating A as 90 upon B. So A is equal to 90 upon 20. So as you can see, 90, 20 both are integers and A is also an integer. So integer arithmetic will apply. So 90 upon 20, the quotient will be 4. So A will be equal to 4. In the next line we are printing A. So 4 will be printed on screen. In the next question we have to predict the output of the following Java code snippet. So we have an integer A, its value is 10. Then we have a variable B, it is assigned the value A plus plus. Now this command can be broken into two separate commands. First will be B is equal to A, second will be A is equal to A plus 1. Now A plus 1 runs after B equal to A because this is postfix operator. In prefix operator, it will go the other way around. So here B's value will now become 10. Now this command will run and A will become 11. In the next line, C is equal to A, so C becomes 11. Now we are printing A, B and C without any spaces. So first A will be printed, A is 11. Now B will be printed, B is 1, 0, 10. Now C will be printed, which is 1, 1. So option A is the correct answer. So in the print statement, you can see that there are double quotes which denote empty string, as there is nothing between the two double quotes. So it will be printed as A, then an empty string, then B, again an empty string, then C. In the next MCQ, we again have to tell the output of the following Java code snippet. So we have a variable A that is assigned the value of -8. Then we have a variable B that is assigned the value of 3. Now C1 is equal to minus A plus B. So this command can be broken into two commands. This is a prefix operator. So firstly, A will be equal to A minus 1. So A becomes minus 9. Next, C1 is equal to A plus B. So minus 9 plus 3 becomes minus 6. So C1 is equal to minus 6. Now C2 is equal to A minus plus B. So C2 is equal to A minus plus B. This is a postfix operator, so this command can again be broken into two commands. The first one will be C2 is equal to A plus B. The second one will be A is equal to A minus 1. So here C2 will be equal to A is equal to minus 9 and B is equal to 3. So minus 9 plus 3, that is minus 6. And A will be equal to minus 10. Now we are printing C1 equal to C1. So C1 equal to minus 6, comma C2 equal to C2. So comma C2 equal to minus 6. In the next question, we have to find out which of the following is the correct expression that evaluates to true if the number x is between 1 and 100 or the number is negative. So the second condition is easy to code. So the number is negative. So negative numbers are less than 0. So x is less than 0. It should evaluate to true in both the cases, when condition 1 is true or when condition 2 is true. So we put a or in between them. Now let us write the first condition. The number should be between 1 and 100. It means that it should be from 2 to 99. So now let's write the first condition. The number should be greater than 1 and at the same time the number should be less than 100. This is the first condition, so we put a bracket here, and this is the second condition. Now let's see which of these following options are correct. So in A part, we have 1 less than x less than 100. Here what will happen is, this gets evaluated first. So x has to be greater than 1. If this gets evaluated to true, we have a boolean on this side, then a less than operator and an integer on the other side. So we cannot have an operator like this where we have boolean on one side and an integer on the other. So this will give an error. Option B is same as what we have written, so option B is correct. In option C, we have written x should be less than 100 and at the same time it should be greater than 1 and x is less than 0. So in the question we have either condition 1 is true or condition second is true. In this we have put an and between them, so it's a incorrect option. In option D we have 1 greater than x greater than 100. So in this we have the same problem as we had in option A. x should be between 1 and 100. So this gets evaluated to false. Now we have a greater than sign with false on one side and 100 on the other side. This again will give us the same error. Thank you. We'll see you in the next lecture.